Hey guys, what's up? So, welcome to another video of CHE 101, and today we will be talking about how to plot and how to read points on a ternary diagram. So, just a quick review. A ternary diagram represented by an equilateral triangle, so it's this triangle. It is used to plot mass or mole compositions of a ternary system. The vertices of the triangle, so these three, represent one component systems, and then along the sides are the two component systems, and inside the triangle are three component systems. Now, for convenience, I would put the solute S here at the top vertex. I would put the water here, represented by A, at the lower left vertex, and the organic solvent, represented by B, at the lower right vertex. S sometimes would mean a liquid that dissolves well in both water and an organic solvent, right? So one of the things that may confuse us is the way the markings are placed on the diagram. So some are like this. You would notice that from 0 to 100, it runs in a clockwise direction. So some other ternary diagrams are designed in an opposite manner. So it runs in a counterclockwise direction from 0 to 100%. Now I suggest you focus on the segments that are opposite to the vertex of the corresponding component. So it's like how I made or how I modified this diagram. So let's say at this vertex, the opposite segments. So these are the horizontal segments in red. It's similar to the water and the organic components. So I highlighted the opposite segments in green and blue respectively. Now remember that at the vertex, these are pure one component systems. So this means that, for instance, at this vertex, vertex A, it is 100% or pure water. At the blue vertex B, it is 100% of the organic solvent, and at the red vertex, it is 100% or pure solute. And then at the sides are two component systems. Now notice this. Let's say this side, which runs along S and A. If you notice, this side is only composed of either the solute or water, but there's none of the organic component, and that could be thought of as 0% in B. Now, this vertex is 100% in B. So it would only make sense that as you go from the far end of this from this side approaching this vertex, it would only make sense that as we go nearer, the percentage in B increases. So this is 0% in B, this is 10% in B, 20%, 30%, and so on until 100% in B, which makes sense because of these markers. All right. Now, how do we plot points on the ternary diagram? We use that idea to plot specific specific ratio of components of a mixture. So let's try these three. Okay, so we will represent them with brown points. So first up is point P1, represented by 20% in S, 20% in A, and 60% in B. So 20% in A, let's begin with the side that is farthest from the S vertex. So it's here. So this is 0%, this is 10%, and this is 20%. So we know that the point lies somewhere here. Next is 20% in A. So let me mark that. Okay, 20% in A would be, okay, let's start here. This is 0% in A. This is 10% in A, and this is 20% in A. So it would lie somewhere here. Okay. Now, in actuality, when you plot or when you identify two segments that represent any two of these components, that actually suffices to locate the point. So here, this is the 20% in S, and then this was the 20% in A. So they intersect at this point. So this will now be our point P1. Well, just to check if this is the 60% in B. So this is 0% in B, 10% in B, 20% in B, 30, 40, 50, and 60% in B. So it's correct. So any of the 2 points will suffice to tell you the exact location of the point. Let's go to point P2. So that is 20% in S, still here. 70% in A. So 70% in A would be, this is 0%, this is 10%, 20%, 30, 40, 50, 60, and 70. All right. And they intersect here. So this is point P2. Just to check if it's 10% in B, this is 0% in B, 10% in B, and we got it right. And then finally, point P3, which is 40% in S. So that will be 0, 10, 20, 30, 40% in S. Okay. 30% in A. So that will be 0, 10, 20, and 30. So it's here, 30% in A. So that will be at this point, point P3. So try to check if it is exactly also 30%, if it is also exactly 30% in B. Okay. So that's how you plot points. Now, how do you read points? Okay. So let us try to read points P4, P5, and P6 and identify their exact compositions in S, A, and B. So let's start with P4. So P4, okay, let's start to determine first its composition in S. So S is represented by the red segments. All right, so this is 10% in S. This is 0% in S. This is 10% in S. All right. So P4 is 10% in S. All right. How about in A? This is 0% in A. This is 10% in A. This is 20% in A. And this is 30% in A. So P4 is 30% in A. And of course, finally, percentage in B. So this is 0% in B, 10% in B, 20, 30, 40, 50, finally 60% in B for P4. Right? Now again, it would make sense that the sum of the percentages will be equal to 100 since that is the total composition of the mixture. So it would suffice to know two of the compositions, and then you can simply subtract from 100 the sum of the other two to determine the third composition. So let's try that. For point P5, P5 is here. So okay, let's determine the percent composition in S. So that will be 0, 10, 20, 30, 40. P5 is 40% in S. And then percentage in A, that will be 0, 10, 0, 10, 20% in A. And then from here, let's try to subtract. So 40 plus 20 is 60%. And then subtract that from 100, you get 40% in B. And just to check if P5 is indeed 40% in B, all right, so we start from here. This is 0% in B, 10, 20, 30, and 40. And again, we got that right. Finally, for point P6, all right, so this is 0% in S, 10, 20, 30% in S. For percentage in B, or rather in A, this will be 0% in A, 10, 20, 30, 40, 50% in A. And again, subtracting 30 plus 50, which is 80, from 100, you get 20% in B. So I leave the checking part to you. All right. So that's it. So we learned how to plot points on a ternary diagram. and we learned how to interpret composition mixtures that are plotted on the diagram. So that's all from me, and I hope you learned something valuable today. Thank you very much.